Good afternoon, everybody. Another beautiful day. You guys are doing chemistry with me. And very successfully, we are going forward with Unit 4. And in the meantime, I have forwarded you guys this Unit 3 reviewing. How many done that? Raise your hand like if you started that already, Unit 3. Oh, cool. Girls? No boys? We would soon. Anyway, how would you find that? Easy or harder? Some are harder, some are really challenging. Yeah, challenging. That is the nature of Unit 3. But trust me, once we go on with all these units, Unit 3 is disappearing because different parts of Unit 3 are merging with other units. So at the end of the day, there is nothing that you can find separately from Unit 3. But trust me, if you, for the term test, if they are only giving you guys the very first 2 units, they are adding more from the second unit. But when they are done with the third unit, they are adding more and more questions from the third unit because Unit 3 is really challenging. So make sure that you are doing everything of the Unit 3, then you will feel really comfortable. And we're going to do this exam, like once you're done with Unit 3, everything, like the reviewing and everything, then only I can do the exam. It's not I'm giving the exam that you don't have enough knowledge, so I can make like really challenging questions. So that is not the way. The exam way is supposed to be after you guys have saturated with the full knowledge. If I am giving harder questions, if still you can answer, that's supposed to be the real successness of any exam. So I'm going to conduct that kind of exams. But so that before that, I want you guys to finish everything of Unit 3. And I want you guys to gather a couple of these harder questions because I told you guys in the middle of this Unit 4, I'm going to do one full day like Unit 3 questions. So unless otherwise I can go continuously, otherwise just gather if you have any difficult questions from the tude that we're going to do, like maybe in another 2 more weeks or so. Let's do a couple of questions from tude book, okay? So we started Unit 4, which is like, as I have learned from you guys, it is not that difficult. Unit 4 actually is not hard, it's easy unit. Only thing is you're just gonna go through these reactions and memorize those and everything. Okay, last week we started from these 6 gas laws. All are derived from ideal gas equation PV equals nRT. And then the very first thing we talked about the Boyle's law, pressure volume relationship when the temperature is constant. Pressure and volume are inversely proportional to each other. But we need this a simpler equation P1 V1 equals to P2 V2 to do these simplest calculations. These calculations are going to be a little challenging again when these are connecting to equilibrium, 12th unit. Yeah, but it's all right. Unit 12 is really beautiful, and once you know that students get this real theory, sometimes the Unit 12 become their favorite. They have stuff to do, but still challenging, but still it's not like not feasible, it's feasible unit. Okay, then we did couple of questions, and question number 9, is it homework?
Yeah.
Okay. Okay, answer P2, 250 Pascal. Got it? Well done, well done. Everybody? Yeah. Still, I'll give you guys a little explanation. Volume of an ideal gas sample is 200 cubic decimeter. So the V1 is 200 cubic decimeter. I don't know whether I need to change the units. I'm just going to leave it as it is for now. I'm continue. When the pressure is 2.5 Pascal, that again I don't know whether I need to change it. I'm just going to keep it as the very first pressure, that is a P1. Find out the pressure of the gas sample. So they are asking then P2. We need to find the P2 then. So we have to subject P2 here, which equals P1 V1 over V2. Come down. They are saying at that time the volume is 2000 cubic centimeter. Then I get the hint. Earlier I read that this is the volume in cubic decimeter, but now it's cubic centimeter. So either way you have to change that. So that I'm going to change this 2000 cubic centimeter, multiply with 10 to the power minus 3 to convert it to cubic decimeter because that's easier. Usually always going for higher units are easy, but this time I'm going lower because 2000 is a big value. So that I have all this data I needed and I have clarified everything. Just do the little substitution. And then cubic decimeter you can cancel off. Only Pascal is remaining. Yeah, that's true. We need the pressure. So the pressure is 250 Pascal. Then we just discuss question number 9. Okay, then we talked about these graphical illustrations. Because this volume and pressure having the inverse relationship, one increasing at the same time the other one is decreasing. So we're supposed to get this kind of a graph. This kind of a graph, usually we call it this hyperbolic curve, because these two are inversely proportional to each other. And then if you go with this equation, V equals K into 1 over P. And if we get volume to y-axis and 1 over P to x-axis, since this is giving this kind of a y equals mx kind of a equation, then our graph is supposed to be a straight line going through the origin. And since PV is constant, if we draw a graph, PV versus pressure or even volume, that's supposed to be constant. So always we are getting a parallel line to x-axis. Okay, those three. Anything here? Any question? Okay. And when you are increasing the mass, volume is increasing, so that either whatever these graphs we already done, so the new graph is supposed to be shifting to upwards. And with the temperature again, what happened with the temperature, thermal expansion, again the volume is increasing, so again the graphs are moving, lifting upwards. Okay, these are your resource book explanations. Then the Charles law. Boyle's law is shorter, Charles' law is little longer than that. Again, constant pressure. This says volume is directly proportional to temperature. But to do calculations, we are deriving this little equation. V1 over T1 equals to V2 over T2 V1 divide V2 equals T1 divide T2. Okay, this question we did at the class, and question number 11 is homework. Is it this homework? Minus 148 degrees Celsius. Asian, if you did this correct? Why? What went wrong? Maybe some sort of data is wrong or something?
Yeah, I think so. The data is wrong. The data is wrong. It's given as 10 to the power, 40 cubic centimeters and 10 cubic meters.
40
cubic centimeters. That's right. I got 124,999,727 Celsius.
Anyway, digits are correct, I guess. Or maybe the printed copy is wrong, I guess then.
Did you get the same answer? 127 minutes. 24 minutes.
Hang in. What is this for? All these, like all your books are having this, is like cubic centimeters?
Yeah.
Oh, that's a mistake, I guess then.
Cubic, whatever.
Why?
Seriously. You convert it Kelvin. Get it converted Kelvin. Yeah, and then convert it. Yes, it's given in temperature 30 Celsius, right? So you convert the Celsius.
No, Celsius වලින් සොයන්න. In Celsius, you want to get the answer.
Miss, can you do it with like cubic centimeters and?
Yes.
Because you hold on. So V1 over T1 equals V2 over T2, right?
Hang on. So the reason is asking, can we do this without converting this to Celsius? Can you do that? We can't. Why?
Yes.
Because we were deriving all these equations from ideal gas equation, which we need the absolute temperature, Kelvin temperature. Anyway, I don't want to do this for cubic centimeter. Let me explain this one. Anyway, I want to change your note then.
It has to be covered. This looks very weird though. This looks very, very suspicious though.
Okay, let me explain this one. Sorry for this printing error. At 500 Kelvin, okay, so the T1 is 500 Kelvin and inert gas sample is volume is 40 cubic meters, so that is 40 cubic meters, V1, when the volume is 10 cubic meters. So V2 is 10 cubic meters. They are asking T2. Subject T2. Do the substitution. Just cancel off these two. And then the value comes in Kelvin. Minus 273. It's minus 148 degrees Celsius. Copy this down.
So when you're using like ideal class, the in the
Na.
equation,
Na.
any ideal class, in the equation it has to be like in the
Kelvin.
derivation, Kelvin, right?
Kelvin.
Yeah, that's what it is. And then you use convert it to Celsius. So I want to find. Oh, sorry.
I won.
Yeah, it was a. I'm sorry, I didn't mean it like that. I didn't mean it like that. I didn't mean it like that.
That's for kindergarten. Yeah,
No, it is.
that's for kindergarten.
No, I didn't mean it.
For kindergarten,
I didn't
those.
mean it. I'm sorry. That was very bad. I'm sorry. That was mean.
Okay, copy this anyway. Ranati, so what was your answer? You got this? Oh, really? You were just thinking maybe it's supposed to be 40. Ah, wow, see. Ranati, she has done with 40 cubic meters.
Really?
You?
Seriously?
Kelvin.
I mean, it's not complicated.
Yeah, that's okay, that's good. But they are asking in. If you got from Kelvin, just highlight this one. Let's say this is an MCQ question, you are not getting marks then. Remember last time this happened to a couple of you. Like there were 5 MCQs, couple of them are given in Celsius and couple of them in Kelvin. So the one of the answer in the MCQs is this one, another answer is this one. Which one you choose? Understood? Highlight this and show.
That's something I would choose the wrong answer. Yeah, something very I would say.
No, you're not going to do that now.
Huh?
Because now you are alert and now you memorize your silly mistakes. Always try to memorize your own silly mistakes because no two people doing same silly mistake. Okay, moving on. Equations derived from Charles' law that says when you increase or decrease the temperature by 1 degree Celsius, volume is decreasing and or increasing by the 273 portions of the initial. If the initial volume is V0, the increase or decrease volume will become V0 divide 273. Are you guys okay here to derive this equation? And you guys are aware that increasing 1 degree Celsius, the value become V0 divide 273. If 2 degrees Celsius, 2 V0 divide 273. If you are increasing, this is plus, and if you are decreasing, this is minus. This part. And these 3 graphs, are you guys okay here? Again, we are drawing this graph, getting this Charles' law relationship. V equals K into T, Y equals mx, line going through the origin. And V over T is constant. So regardless you are drawing it with respect to T or with respect to V, this is supposed to be a parallel line to x-axis. These are very easy, answers are very easy. Perfect crystalline solid can reach when you are decreasing the temperature to 0 Kelvin or minus 273 degrees Celsius. And this again explains this equation. Y equals mx kind of a C graph you're going to get because of this situation. Increasing or decreasing by V0 divide 273 degrees amount of volume. Are you guys okay here? Same way, Pressure increasing, volume decreasing, volume is, graph is shifting down. Mass increasing, volume increasing, graph is shifting up. Combined gas law, we're going to go with combining together Boyle's law and Charles' law. PV over T equals to K. But to make calculations, we need this equation. P1 V1 over T1 equals V2 V2 over T2. And 12, 13. Question number 13. Temperature is, so you can make this like, the last question is also correct because again here the temperature is like really high. 2227. Correct. Everybody? Well done. Why? Okay. Let me read the question for you all. Volume of an ideal gas sample is 15 cubic meters. Okay. So the P1 is 15 cubic meters. At 150 Kelvin and 2 Pascal. So the T1 is 150. P1 is 2 Pascal. Okay, first condition is there. And when the volume is increasing to 100 cubic meters, or the second volume V2 is 100 cubic meters and the pressure is 5 Pascal, then just subjected to knowing everything. So the value is 2500 Kelvin minus 273, so it's 2227. Pascal cancelling off, cubic meters cancelling off, only Kelvin remaining, which is the unit of temperature. Then you are converting it to Kelvin, because again I'm asking the Celsius, asking by Celsius. Well done. Okay, Avogadro's law, both temperature and pressure are constant. So number of moles is proportional to volume. And if volume moles are constant, number of moles in two different containers at same temperature and same pressure are constant. Question number 14. 15 homework. Molar mass of A is 7.5 grams per mole. Well done. Everybody? See, that's really impressive. You all doing homework. Anyway, I'm going to read this. Even if one of you are having a little second thought, I'm going to read it. In a container with a volume of 200 cubic centimeter, 64 grams of methane. We are not working with grams, so we need to convert this into number of moles. So the molar mass of methane is needed, is present at certain pressure and certain temperature. Another container consisting 60 grams of A. Again, they are given this mass and they are asking the molar mass. And again, given these conditions, volume of 400 cubic centimeter, same temperature and same pressure. Okay, so we know temperature, pressure same. They ask us to find this number of moles. So we're going to go with this simplest equation. Volume ratio equals to mole ratio if pressure and temperature are constant. Two volumes are given and number of moles, mass divided by the molar mass is number of moles. So we can find the number of moles of CH2 as 4 moles. Subject the unknown number of moles so that we can find the number of moles. Here 8 moles. And they were also given the mass of that A. Mass divided by number of moles is the molar mass. So that molar mass equals to 7.5 grams per mole. Anything that you want to copy from here, like any step or something? Huh? We did this at the class?
I think so.
Oh. Okay. How come you are not saying that then? Before I explain, just say that. So we can save time. It's okay to disturb for right things. This one again we did at the class.
Yeah.
Are you guys okay with this one now? This is really challenging one to everybody. Every year this is challenging. Dalton's law of partial pressure, this says how many gases are in one single container. Total pressure exerted by all these different gases is the total pressure of the container, so that the gases pressure that contribute from other gases are called the partial pressures. So all the partial pressures together, let's say PC, PD, so on, all together gives the total pressure plus partial pressure we can calculate if we multiply the total pressure with the molar fraction. And this is again using very frequently in unit 12, equilibrium. So this one, Q17 we did at the class.
17, 80 now.
Really? Oh, this is easy. 7.5 Pascal. Got it? You didn't try. Who tried and who got answers? You didn't try. Okay. A gas mixture is composed of 5 moles of O2 and 5 moles of N2. So then the mole fraction is half, you guys know, because 5 moles of N2 and 5 moles of O2 mean altogether 10. Each become like 5 divided by 10 is the molar fraction. So you already know the molar fraction. And they say the total pressure is 15 Pascal. So this is half and this is 15. So it's altogether very easily 7.5. Here I'm just explaining different ways. I have calculated separately this number of moles and then the molar fraction here, so that's again very easy. Just copy down anything you want. Okay, it's really impressive. You all work really nicely. Just keep it up. You guys working really nicely. I just want you to keep it up, that's all. Because for now, I'm not saying this one just to teach you or just motivate you. For now, you all are having these qualities of like very top results, students who's getting top results. You guys are showing those qualities for now. Okay, for now. Losing time, little by little with time. Be somebody that not losing, who's hanging in there. Whoever have the consistency wins. Okay, last part. Kita? $88. Raise your hand. Really? Good. Well done. Okay. Who tried this? Raise your hand who couldn't get the answer after trying. Yeah, this is again little challenging one. Anyway, let's see. Aman, well done. Aman turned into a new leaf, I get, in advanced level. Isn't it? Were you working like this for all of us?
Yes, actually.
You did?
But like I didn't study the last few days. Because like last few weeks.
Seriously? He has studied only for last few weeks.
No, like I didn't study the last.
Ah, you didn't study?
I didn't study.
Because?
I did study.
I'm sorry that I'm laughing.
No, it's fine.
Yeah, but I know the situation.
It's very ironic and
I
it's
know.
very good.
Yeah. Okay. Don't ever raise any pen.
I'm-
Okay. 2-liter flask of nitrogen. This is a special sort of a calculation because two different containers you are mixing together, then you should know what kind of conditions are applying. This is a sort of a different kind of a question. It's really good he has done that. Anyway, so one container with with nitrogen, the other one with the oxygen. 2-liter flask of nitrogen gas at 20 degrees Celsius and 70 atm. Okay, nitrogen 2 liters 70 atm separately, connecting with another 3 liter oxygen pressure is 100. Okay, 100 atm, 3 liter oxygen, but they say same temperature. So I don't worry about the temperature because I have a little idea. I don't want the temperature, so I made the temperature constant. Then they are mixing those two. So this container, they are mixing this 2 liter and 3 liter. Here become 5 liter. So all the nitrogen and all the oxygen are here now. And still they say the temperature is not changing. What will be the final pressure of the mixture? They are asking the final pressure. You are mixing two different gases. Volume is changing. Two different pressures are applying. If we find, okay, if I go with this easy method first. If you use the Boyle's law, because they say the temperature is constant, if you can find these two pressures separately in new container, those two are the partial pressures, then applying this Dalton's law of partial pressure, if we know the separate pressures of these two gases, we can find the total pressure. To find the pressure separately, we can use P1 V1 equals P2 V2. So final pressure equals P1 V1 over V2. So for nitrogen, pressure is 70 and initial its volume is V1 is 2 liter. And for oxygen, initially the pressure is 100 and initially it was in the container with 3 liter. But the final V2 is same now, that's 5 liter in both. If you calculate, you can get separately these two together, separately, but if add these two together, that is the total pressure. Or otherwise, same actually sort of a thingy I'm doing here. See how I saved timing. Okay, so when you are getting same kind of a terms for different equations, don't substitute, don't simplify until you come to the last step. Maybe you can cancel off them. So just let's say you are having R is little complicated. Just hang in until you come to the last step, whether it's okay to cancel off or whether you need to substitute, okay? Anyway, so I'm going to use this ideal gas equation here, PV equals nRT. I'm going to find this total number of moles here first. N equals PV over RT. Okay, so the nitrogen number of moles, 70 into 2 divided by RT, PV over RT. RT constant, so I'm not changing RT. Okay, for nitrogen, it's 70 into 2. And for oxygen, it's 100 into 3. Okay, if you want to calculate, I have given these values because some done that. If you want to check your answer, values are here, but I didn't do that way. So that to find the final pressure, I know RT, total volume they were given as 3 plus 2, 5. I know that 5 liter thingy as well. Only unknown is this number of moles. So that I use this method, separately find the number of moles. So these two together is the total number of moles. So now I'm going to find using PV equals nRT again. This time I'm subjecting P. And then N is the number of moles of oxygen and nitrogen. That's the total number of moles. RT is constant. Now both are in one single container. So the total volume become 5 liter. Okay. So that NT is this part. Number of moles of nitrogen. I'm going to go with another color. Okay. Number of moles of nitrogen. That is this part. Plus number of moles of oxygen. And that is this part. Okay. That is our NT. And then still we have RT here divided by total volume is 5 liter. See, once I am in this equation here, I can simplify RT to RT to this RT because these two RT are common. So I can simplify or cancel off this one to this RT. Clear? And then you have liter here, 2 liter, 3 liter, 5 liter here. So I'm cancelling off liter as well. So what's remaining? Remainings are 70 ATM into 2, 140 ATM. 100 into 3 ATM, 300 ATM divided by this 5. So very easily you can get the answer. There are 2 methods to do this. Got it? Okay, let's copy this from the scratch. Just draw this little diagram first. That's the summary of the question. If you go with this wonderful little like diagram, then the questions are easier to think. Which method you did? Wow, good. The second method he has done. Listen, you tried or you didn't try? Oh, because you didn't have time. Did you do these arms?
Yeah.
Wow, really? Really? You went to Ratnapura? How was the city? Which way is good? City is not good. Town is like nothing is there. Yeah, but the countryside is really beautiful, I guess. Even whenever I'm going to these like places, I live in exactly the middle of the city. So when I'm going to these like remote areas, like you know the those greeneries, beautiful paddy fields. අපි යන ට්‍රිප් එකකට දවස් එක රත්නපුර. සර්ගේ පතල් බලලා සමන් දේවාලේ වැඳලා
So fun session.
කොහෙද තියෙන්නේ බෝපත් හෝල්ස් නාලා. Palmador area is really beautiful. Yeah. If you go inside, like have you been somewhere just to visit? Ah. You didn't see any of my these flexes? No. You didn't see. At what time you passed Ratnapur town? Maybe you were sleeping also?
5:30.
Oh, really? In the morning? Evening? Oh, I guess, yeah.
It's very short. First method is very short.
Shorter if you are not simplifying these RT.
Yeah.
Can I move up here? Okay, the calculation part, basic calculation part actually is done. Done writing, Asri? Everybody done writing? Can I move down here for the second method?
Which energy is counted? Which energy is counted?
They've been to their hometown, I guess.
Inara.
I guess the long weekend having fun them, I guess. Even I given this leave for, I mean the I cancelled class on this Monday because Monday is a power day. But today we can't do that because it's a regular class day. Okay, give to these girls. Is it hot water? Hot water or something? No, once you see it, it's okay. When මම අරයාගේ clear එකක් ගත්තා. And this is me, see. අපි දෙන්න එකට pictures ගත්තා. Seriously. Yeah, he was like, I was like, yeah. Okay. So we are moving to this next part. Basically, the first part is we came through the calculations using the ideal gas equation. That part is done. Then the second part is we are trying to understand the behavior of gases. For that, we are using this curve. So two scientists who discovered that is Maxwell and Boltzmann. So we named this curve as Maxwell-Boltzmann distribution curve. By this curve, they explain behavior of gases. Okay, let's get this. I'm England. Now, what's up here? I'm not going in. Okay. She knows I'm this year. Okay. So, inside this container, let's say we trap some sort of a gas. Each and every single molecule is moving. How? Continuously, randomly, no proper direction, to whatever the direction. Okay. So, each and every single molecule is moving. So, there are how many molecules that are not moving? Staying stationary? 0. No molecules. Okay. So, then they made this little graph taking y-axis to number of to molecule. Okay. Number of molecules. Taking x-axis the speed of those molecules. Whatever the speed, let's say I'm going to get speed as let's say V1, V2, V3, V4, so on. How many molecules with V1 speed? Let's say there were 1000 molecules with V1 speed. Let's say there are like 2000 molecules with V2 speed, 3000, another 1000 molecules with V3 speed, so on. Connecting everything together, they made this diagram that you guys can see. This is starting from the 0 because there are 0 molecules with 0 speed. Okay, so we're doing all these to understand the energy of a system because the speed is directly proportional to kinetic energy. Speed directly proportional to kinetic energy, and kinetic energy is directly proportional to and depending only on what? Last week I just said, we didn't write the note. On what? Kinetic energy depends only on temperature. Temperature. I said this last week. We're going to talk about that today. Okay, so this is how it is behaving, and we are doing this one to understand the energy associated to each of these systems. Okay, before we moving on, I want to explain you guys a couple of these different speeds they are using. Okay, for the very first speed they are using, I'm going to come to this again, but without these words I cannot explain anything. The very first speed is the most probable speed. That actually is the mode value. What's the meaning of mode value? Highly repetitive. Not the mean. Highly repetitive. Highly repetitive. Okay, so what is the meaning of that? Highest number of molecules are showing this speed. The speed that highest number of molecules are showing is called most probable speed. And then the second one is the mean speed. If you know the speeds of each of these molecules, If you add all these speeds together, and if you divide by number of molecules, you are getting the mean value. That is called the mean speed. And then the next one is the mean square speed. Mean square speed. Okay, now you tell me why they are talking about different speeds. What's the reason of that? What's the purpose of that? Let's see that you guys improve your instincts. Okay, so the next one is mean square speed. So they square each of these speeds and they aggregate everything together. Divide by the number of molecules, they get mean square speed. Last one is the root mean square speed. Okay, whatever the speed, mean square speed, that value. So this is the mean square speed. If you get the root value of that, that is called the root mean square speed. Okay, symbols, how you play with the symbols. What is this? This is the speed. And what is this? Square speed. And what is this? Mean square speed. And what is this? Root mean square speed. Understood? Okay, let's do this again. What is this? Speed. And this? Square speed. Sorry. This mean square speed. And then this one, root mean square speed. This is the one we are using. So everything we are doing rest of these to understand this one. And to understand this one, we're going to do this silly question number 19 as well. Yeah, that's silly. Yeah, we can talk about motorbikes. Yeah, anyway, so let's move here with this. And again today we're going to challenge your, you're going to challenge your memory. Let's see how much you can memorize. Listen here. Okay, Maxwell-Boltzmann distribution curve for distribution of speed of molecules. Statistically they were done that, okay. In a gas sample, molecules are in random motion. Since the kinetic energy of molecules in the gas sample is not same. You guys know different molecules are having different speeds depending on the condition. They have different speeds. Kinetic energy different, so that the speeds are different. Number of molecules with very low speed is less, and the number of molecules with very high speed is also low. It simply means let's say usually the kinetic energy is constant. So constant amount of speed is always they are maintaining. So that very low molecules speed with molecules with very low speed and molecules with very high speed is low. The majority of the molecules are getting the majority of some sort of a middle speed and middle kinetic energy. As the molecules move in straight line directions because molecules are not moving in curved paths. Molecules are always moving in straight directions, okay. As the molecules move in straight line direction, that the motion has vector properties such that the molecular speed are expressed in relation. So that the speed also is a vector property because motion has a direction. Most of the molecules have a speed which almost closer to the average speed. The graph representation of distribution of speed of molecules is known as Maxwell-Boltzmann distribution curve. We're going to go through continuously with this one. If you remember, PV equals 1/3 mnc squared by equation, chemical kinetic molecular equation, that we have written this equation under this pressure units. So up to that we are just going continuously, okay. So this kind of a graph we are always getting. See, the graph is always having like no zero here, and always it is more like spreading towards this direction, to the energy increasing direction. And you guys can see this side is smaller and this side also is smaller. See the number of molecules, blue molecules, and here this blue molecule is less. Then number of molecules with the average higher speed is high. Clear that? Okay. So let's first go through this little part and then move on to the next part. Okay, let's try this topic and points together, you and me. Okay, topic Maxwell-Boltzmann, loud and clear. Look at the screen, okay? Maxwell-Boltzmann distribution curve for distribution of speed of molecules. In a gas sample, molecules are in random motion. Since the kinetic energy of molecules in the gas sample is not same, they have different speeds. Number of molecules with very low speed is less, and the number of molecules with very high speed is also very low. As the molecules move in straight line directions, that the motion has vector properties such that the molecular speeds are expressed in relations. Most of the molecules have a speed which is
almost closer
to the average speed. The graphical representation of distribution of speed of molecules is known as Maxwell-Boltzmann distribution curve. What is it? Maxwell-Boltzmann distribution curve. Yeah, these words are like little weird, but you're going to go on continuously, then you're going to be familiar with those. Let's give it a little try whether you have the memory. You are challenging to yourself. There are no competition with others. Don't draw it without my support. Yeah, on a scratch paper, that's all right. Okay, now you look at your note. Plus, you guys can read together. When you are reading out loud, there are two ways to memorize. When you are seeing something visually, you get the memory. And your voice, you can hear your own voice. It improves your memory. Okay, Maxwell-Boltzmann distribution curve for distribution of speed of molecules. In a gas sample, molecules are in random motion. Since the kinetic energy of molecules in the gas sample is not same, they have different speeds. Number of molecules with very low speed is less, and the number of molecules with very high speed is also very low. As the molecules move in straight line directions, that the motion has vector properties such that the molecular speeds are expressed in relation. Most of the molecules have a speed which is almost closer to the average speed. The graphical representation of distribution of speed of molecules is known as Maxwell-Boltzmann distribution curve. Okay, the very first day today you feel like it's uneasy, but you're gonna hear this continuously. Are you guys okay with that part? Okay, then you're gonna draw this one. It's not necessary to draw these because I am using this one just to make you convincing. Otherwise, you never usually can measure like, the 1,000 gas particles, because one molecule, one mole has like 6.023 into the power 23. Hang in, don't write, don't draw. Come on, hang in. I'm explaining things. Okay, so your y-axis, number of molecules with certain speed, or otherwise each number of molecules. Divide by total number of molecules, let's say 10,000 or let's say 20,000. Okay, then 1,000 divided by 20,000, let's say here. Or then the second point, let's say 2000. 2000 divided by 20,000. So this is the molecular fraction. Either number of molecules or molecular fractions can be used. For unit 4, ඔයාලා තම පුංචි නිසා ඔයගොල්ලන්ට තව දේවල් බැරි හින්දා ඔයගොල්ලන්ට තව chemistry බැරි හින්දා we are just going with simply the number of molecules. But when you are being like when you become like stronger, prominent with chemistry, when chemistry become yours, when you are doing unit 11 chemical kinetics, then you are using molecular fraction. Okay, for now you are going with the number of molecules. Don't worry, you're going to be there soon, and you're going to write your exam in another like 2 more years. Yeah, the time is passing like bullets, and which is deciding your future. Wow. And then the other side, තම පුංචි නිසා we are going with speed. ඔයගොල්ලෝ ලොකු වුණාට පස්සේ we are going with kinetic energy. So that's why I have written these within bracket. Or molecular fraction comes with chemical calculation, chemical kinetics 11th unit, and O kinetic energy, that is again with the 11th unit. Okay, when you are drawing this one, see, this is let's say my full length. I divide into 2, and if I go like this, parallel, like the symmetric normal bell shape, but I don't want that, so that I divide this half, this first half to again another half. Okay, then from here, I'm starting the graph, go from here and then all the way to here. Understood? So that you never make symmetric graphs. Don't make this graph symmetric, that's wrong. Understood? Start from 0. Somehow the speed is limiting, the kinetic energy is limiting, so it's going back to 0. Okay, you have enough speed, enough space over there. Just copy this. Yeah, I can. I'm in a class right now, but we can talk a little bit. Yeah, but they are doing a diagram. Didn't tell me. No, yes, yes.
a system, the particles are not moving like correct. So there's a thing. The way the graph is sketched, starting from 0, 0. So speed is 0, and then I'm technically no, let's not answer one question. Let's answer one question. Because it's 0, 0. So particles in 0. Oh, okay. Here particles 0, 0. That makes sense. That makes sense. Did you get that? Yeah. Did you see what she raised? Did you see what she raised? Yeah, do you read it? No, she didn't read it. It's like a slide.
Sorry, guys. I'm on downstairs. Okay. Oh, okay. Most probable speed, mean speed, root mean square speed. Don't worry, we're going to get to know about all those words in a bit. Okay, so the one by one, we're going to talk about these properties of this graph now. Moving on. Okay. So the topic, important points to consider in distribution of speed. Important points to consider in distribution of speed. Okay, I'm going to go one by one. The very first one, as you guys know already, the curve starts from origin. Since no number of molecules with zero speed is 0. Okay, there are no zero molecules. So it's 0. So you are starting from 0. Since molecules are at continuous random speed, always some sort of energy is there, kinetic energy. So always they are continuously moving. Okay, so that this is starting from 0. So that this is starting from 0. Okay, that is the very first one. Okay, then the second one, the curve is not symmetric. The curve is not symmetric and spreads more towards right. So the curve goes towards right. This is because most of the molecules have a higher speed than the most probable speed. Okay, so this is the most probable speed. So this is the most probable speed, the higher speed. This is the most probable speed, this one. But a lot of molecules are having greater speed than the most probable speed. So the graph is always spreading towards the direction that having the higher speed. That is the second one. And then the third one, the maximum point represents the mode, value appeared the most, value of speed, which is known as the most probable speed. So the maximum point is called the most probable speed, the speed of the maximum point. And then the next one, fourth one, since curve shifts towards right, then the mean speed, if you get the average speed, is also located towards right. And it's higher than the most probable speed. Okay, mean speed, also root mean square speed also is greater. Root mean square speed also located towards right. It is higher than the most probable speed and the mean speed. If you get this highest, the speed that highest number of molecules are showing, that is the most probable speed. This is greater than that, and also this is greater than mean speed, or this one. Root mean square speed is so that the highest. Okay, that is very obvious. And then another thingy. Okay. Let's say n number of molecules are here, And to this, I'm adding another n number of molecules. What happened to the shape of this container, this graph? Shape.
Does the shape change?
Okay, to change the shape, what's supposed to be changing? Number of molecules with different speeds. Okay, speed depends on what? Kinetic energy. Kinetic energy depends on what?
Temperature.
Temperature. As long as temperature is constant, so that number of molecules with certain kinetic energy is not changing. So that this is shifting upwards, but still maintain the same shape. Clear that? Okay. If we increase the temperature,
the kinetic energy increases, so the graph goes more.
yeah, it's supposed to move to this direction. Well done, well done. Okay. See, impressive. Okay, so that's the sixth one. Area under the curve is proportional to the number of molecules. That's why if you add more molecules, the graph shifting upwards to increase the area. In the gas sample, therefore, for a given gas sample, even if we change other parameters, area is constant. Okay, so that even if we change the temperature, even the graph is moving to this direction. Okay, this red area is supposed to be equal to this orange area. Clear that? These two are supposed to be equal to each other, so that whenever the temperature is increasing, this number of molecules with the most probable speed is supposed to be decreasing. Because it's like a longer something is here, then you are dragging it, it's become like shorter. Let's say this is the most probable speed, so it has become shorter when you are dragging it. So that this is become, so that less. Okay. Then the seventh one and the eighth one is the instead of speed, for x-axis, what else we can get? Kinetic energy. Y-axis, instead of number of molecules, we can get molecular fraction. Those two are the 7 and 8. Anyway, could you be able to memorize all these if you read all these together? I don't think. New words, new things. Okay, let's read only these two, then let's try to fill it. Okay, let's go with the topic from the topic. Okay. Important points to consider in distribution of speed. Number 1. The curve starts from origin. Since number of molecules with zero speed is 0, since molecules are at continuous random speed. Number 2. The curve is not symmetric and it spreads more towards right. This is because most of the molecules have a higher speed than the most probable speed. Okay, let's fill those two. I'm going to leave this here.
There's an extra blank, right?
Yeah.
Ah,
Really?
yeah. It's
Oh.
an extra blank.
Yeah. Is there anybody who you have like doing exams in 28? No? Who?
Like, well, I know
People you know?
like my cousins and stuff.
Oh, your cousins?
Yeah,
Are they doing good?
yeah, yeah.
Really? Okay, let's read. The curve starts from origin since number of molecules with zero speed is 0, since molecules are at continuous random speed. Number 2, the curve is not symmetric and it spreads more towards right. This is because most of the molecules have a higher speed than the most probable speed. Okay, I'm moving to third, fourth, and fifth together. Okay, number 3. The maximum point represents the mode value of the speed which is known as most probable speed, which is MPS short form. Number 4. Since curve shifts towards right, mean speed C bar is also located towards right and is higher than the most probable speed. Number 5. Root means square speed. C squared bar, root value of that. Root C squared bar. Also located towards right. It is also higher than the most probable speed and mean speed. Okay, let's give it a try. Okay, number 3. The maximum point represents the mode value of speed which is known as most probable speed MPS. Since curve shifts towards right, mean speed is also located towards right and is higher than the most probable speed. Root mean scarce speed also located towards right. It is higher than the most probable speed and mean speed. Number 6. Area under the curve is proportional to number of molecules in the gas sample. Therefore, for a given gas sample, even if we change other parameters, area is constant. Look at the screen. Number 7. Instead of speed in x-axis, kinetic energy can be considered. Number 8. Instead of number of molecules in y-axis, fraction of molecules can be considered. Okay, fill that part. This is Minara's mark. Minara's not well.
Okay.
This, just save yourself because this flu is continuously going on. Like half of my Ratnapura students are like Niti Bagita. Like 2-3 days they were in bed, and you know what you had? Really? I think it's like concert for bad. I don't know, it's bad for everybody. Some kids are like complaining really, like they are coming to the class but still like I don't know, like coming is not even like safer to everybody. But then, okay, let's move on back. Number 6. Area under the curve is proportional to number of molecules in the gas sample. Therefore, for a given gas sample, even if we change other parameters, area is constant. Number 7. Instead of speed of x-axis, kinetic energy can be considered. Instead of number of molecules in y-axis, fraction of molecules can be considered. Okay, so the next part we're going to go on to understand the meaning of exact meaning of these different speeds. Okay, different type of speeds. Do you have these 4 subtopics here?
Yeah.
It's there. Most probable speed, mean speed, root means speed, square root means speed. Okay, those 4. So the very first one, most probable speed or MPS. This is the speed that maximum number of gas molecules can exist. So usually we call it the mode value of the speed. Okay, fill that part. I've added this Gaynor, your personal initiator, to your group. Did you guys see that? Yeah, I've added, yeah, not today, yesterday, or maybe I don't remember. Anyway, so if you want to have any question, just ask to the group, he would answer. Make the group like, the standard, going with these proper conversations with questions, Other groups, they do that. Only your group is still silent, and maybe you don't know that he is there. Yeah. Okay, so again I'm reading. Most probable speed, MPS. This is the speed that maximum number of gas molecules can exist. Therefore, this is mode value of speed. Okay, you are done with that. And then the second one, mean speed, C bar or U bar. We don't use this one anyway. They were given this symbol. By dividing summation of speed of all molecules by number of molecules. This can be obtained. Okay, let's say we have n number of molecules starting from 1. So the first speed is C1. Second speed, the speed of the second molecule is C2. Speed of the third molecule is C3. Let's say the last molecule is nth molecule. Speed of the nth molecule is Cn. Number of molecule is n. So we add all these speeds together and divide by all the number of molecules. Number of molecules doesn't have a unit, but the speed unit is meters per second. So that the C bar, mean speed unit, also is meters per second. Clear that? Okay. Copy these and fill this. Okay. Next one is mean gas speed by dividing summation of squares of speeds of all molecules by the total number of molecules. Okay, the first molecular speed is C1, you get the square value of that. Second molecular speed is C2, you get the square value of that. Third molecule speed is C3, you get the square value of that. And the last, let's say the nth number of molecules are there. So the nth molecule's speed is squaring. And then you add all these together and divide by total number of moles. You are getting C squared bar. And here you are getting the square value of speed. So that you're going to get the square of this one. So ms to the power minus 1 square become m squared s to the power minus 2. Clear that? Okay, so let's read this again together. Let's read this together. By dividing summation of squares of speeds of all the molecules by the number of molecules, this can be obtained. Okay, feel this. It's not hard, but still I want you guys to memorize better. Okay. By dividing summation of squares of speeds of all the molecules by the number of molecules, this can be obtained. Okay. And then the last one, if you get the root value of that, that becomes the root mean square speed. So this can be obtained by taking square root of mean square speed. Okay, so this is the mean square speed. And if you get the root of that, if you get the root value of that, that's become the root mean square speed. So whatever the value we have taken earlier, only you are giving the root of that. Clear? Okay, copy this. Oops. Akash, any problem? Meter squared per second squared. Then you're going to get the root of that. Then again, root means square speed have the same meters per second unit. Okay, this is again meter squared per second. Root of that is the meter per second. It takes time to show, appear here things I'm writing. Something wrong with blue. They are like doing editing, I guess. Okay, this silly question to understand this. Yeah, I know, but I want you guys to do this to understand this. Anyway, I'm just showing, you are just writing, just copying, otherwise it takes like ages to simplify. There are 25 motorbikes in a track with different speeds as in the following table. Okay, if I count all these together, that's 25, then I know there are altogether 25 bikes. Okay, they are asking these questions, find out most probable speed, mean square speed, and root mean square speed. All those four that we talked about, we're going to find out those. What is the most probable speed? MPS. Yeah. Yes.
It's the mode.
Yeah. Yeah. Which one?
6 plus
6. So it's supposed to be, the speed is 110. Got it? Okay. So that we are writing, don't write, just listen. So that the most probable speed equals 110 kilometers per hour. And then they're asking the mean speed. Okay. How many bikes with 70 kilometers per hour? 1. So you have only 70. I'm going to add them to get the mean value. Then, how many bikes are having 80 kilometers per hour? 2. Then, 80 plus 80. Plus, then I want to add 90 into 3. 100 into 4. So that I'm going to go like this. Not like adding like 80 by 80, 80 plus 80, 90 plus 90 plus 90, so on. Number of bikes with its speed. So, okay, 90 into 3, 100 into 4, 110 into 6, and so on. If you add all those together, the value is 2680. If you divide by 25, you are getting mean speed, which is most probable speed is, mean speed is 107.2 kilometers per hour. Clear? Okay, now copy this. This is there, I guess. This is there. Question is there. Okay. Copy this. Okay, so the next part. You can go on like you don't want my support now. Yeah, now what you're supposed to do, you're going to square each of these and multiply. Square each of these and multiply. Huh? No, never, never. This is just, that's why I said this is a silly question. Now you know what is these terms, these four terms. To get understand these terms, I'm not only doing this. They never give questions regarding motorbike. Or even with real molecules, they would never give. See, each of these, get the square value and then multiply with the number of motorbikes and then divide by 25. Then you are getting the answer as 11,768. You guys have to copy this. That's all. Then you know what is this mean square speed. My daddy.
See if there's like a root value for 100, like 11,760. I want to see if like there's a root value for 11,760.
Oh.
I don't think that is right. Is there?
Do you know how to get the root of those? Like the simplification? Yeah. Are you doing maths? Ah. Can you are doing bio or maths? Bio. Finished. Okay. So this one, you can use the log or you can use the normal like this. Aman knows this method. Just get the root value of that. That's 108.4. Now you guys can see if you compare all the other values, this is the largest one. Okay, even here we are using the real world like the bicycle space. But if you are going with molecules, these values are really smaller. So to make it little more easier, they are using the largest value out of these, which is the root mean square speed. Understood? Okay, so just copy this. Could you get the answer?
It's a long process.
Did you get one at least?
Huh?
Did you get one? The first digit? Oh. What is the shorter method?
Huh?
What is the shorter method?
I think the log is pretty easier.
But usually I don't recommend log. I want you guys to, huh? To do normal like root.
Like-
Okay, maybe if you feel like it takes time for this kind of a calculation, just use the logbook. Otherwise,
I know I use the log.
yeah, logbook takes time. That's what I'm saying. You always have to go with your own methods. That's easier. Math people can find methods easily, then bio people can ask the methods from math people. You absent last week, Thank, isn't it? Because, really? See how calm the class is now. Now the class is going like standard advanced level class. Isn't it, Aman?
Yes, very much.
Because Aman is calm, I guess, now. Concentrating, focusing.
There's a word for that in Buddhism. There's a word for that in Buddhism.
සම්මා සතිද? සමවදිනවා කියන එකක් තියෙනවා. සති. සති. සම්මා සති. Samavadina is on the closer, but Samavadina word never used in this in this Buddhist book, so I never heard someone. Samavadina thina neda sit there. Huh? Yeah. Dhyana වලට කියන්නේ Samavadina කියලා. What is dhyana කියන්නේ බලන්න? What is dhyana?
Dhyana is like
Not arms. Like it is a special mindset, I guess. That is sati. Come back. See, so that shush. This is chemistry. This is not Buddhism. Like Buddha Sishtacharya and something. That's good. Learning a different. Did you guys video? Like the very first when I went to my postgrad, I'm Buddhist. When I went to Canada, then they asked, what is the base of Buddhism? What are the principles of Buddhism? Okay, explain. Okay, these white people they're asking, what's the base of Buddhism? I didn't know like anything. Then they had like all those like free books, and they're having like in those temples there are lots of like English Buddhism free books. So when we went to the temple, then my auntie was like, then I was just reading. Then only I understood what is Buddhism. Like from the beginning we learn about the Buddhism, but still we don't know what is the base of Buddhism and why we are following that and what are the most important parts of that. Anyway. Now I know what is Buddhism. Anyway, since root means gas speed is larger than others, to represent the gas sample, root means gas speed can be used. Let's read this. That's why we are doing this calculation to get here, because that is the largest out of all those different speeds. Let's read this. Since root means gas speed is larger than others, to represent the gas sample, root means gas speed can be used. Okay, I think there is a space there. Aman, you are half Muslim or full Muslim?
half Muslim, half Buddhist.
Seriously, then එතකොට එයාත් මුකුත්ම දන්නේ නැහැ වගේ he was pretending like මම Muslim. Okay, what religion you are practicing? Really? Then you should know both.
I did. I said. I did.
No, you said Mama Muslim.
Yeah. Manu, I said Mama Muslim, but I know this stuff.
Really?
Yeah. I did. You don't listen.
Anyway. Okay, you guys already know this diagram. Okay, Aman, explain this diagram, this graph. What is it here? Number of molecules higher, then the surface area is greater, but the shape is not changing because the molecular speeds are same, so that each fraction is not changing, so that most probable speed, mean speed and root square speed are not changing. Okay, so let's read that part. Effect of number of molecules on distribution. You don't have calculations from this part, but logical critical Do you guys know what are the most difficult questions of our final paper?
No.
You didn't come across when you are going with the first, second, and third these two book questions? Which questions are harder?
Yeah.
Okay, very first 1 to 30 questions are coming from normal, these calculations and everything. Then 31 to 40 are A, B, C, D kind of questions. There are 4 statements, then A, B correct, B, C correct, those on. Then the last part is the 2 statement questions, 41 to 50. So this 31 to 50, there are no calculations, very short questions, but almost all students are feeling like those are the hardest. If you lose marks, usually for, let's say, this is how you are losing your marks. Out of very first 30, you are getting, let's say, like 29. Reality, you are doing that. Out of second one, let's say you are getting like 6 marks. Out of last 10, you are getting 4 marks. Out of 50, all of a sudden, your marks is 39. That is not enough. You have to reach, to get this safer level, you have to reach like above 42 for chemistry. So, see this part, what we are learning, you feel like it's really easier. But the logical thinking, that's what I'm saying. Chemistry is a separate language. It's not a subject. If you understand the language, whatever the word people are talking, then you understand that. It is not you are going with the subject. If you do a subject, you know the principles, then you know how to apply. That's done then. But that's why these parts are harder. So that's why some people do these questions separately. And even in my, like, I don't do separately, but I'm asking you guys when we done, like, I'm doing like more than about like 35 full papers. Then I ask you guys to go again separately with like 31 to 50 questions of each paper. So let's say if you do 10 papers, then you have like 100 questions. 20 papers, you have 200 questions, and so on. Okay, so this part is easier, but when you are answering, like, you have to think, you're supposed to analyze, you're supposed to have the best memory. They are not directly asking something from the memory. So memory plus then logical and critical thinking. But still, they are not asking one single question twice. So the innovation, so thinking as something new, everything's supposed to mixing. That's why these questions are harder, Isari, but it's really all right. Don't get disappointed. Trust me, all my top 10 students, usually not from Colombo, from Ratnapura, this is the first time I'm doing this, this like in another this group class. So they are always reaching 100, almost 100, not exact 100, maybe 99 point something. They are reaching there, 50 out of 50, they are reaching there. So just follow my instructions, that's all. Follow these instructions. Anyway, effect of number of molecules on distribution. Yes, Ali.
See, again, She's laughing because of like the motivation.
Yes, I can do this. I can do this. Yeah. When the number of particles get increased, the number of, no, this is my turn.
Oh, sorry.
Now, understand. ඔන්නටදී hasty වෙලා mistakes කරගන්න එපා final exam එකේ. When the number of particles get increased, the number of molecules with certain speed also getting increased by same extent. The shape of the curve remains constant so that if the number of moles are considered in y-axis, area under the curve get increased with the same shape. Also, the most probable speed, mean speed, and root mean square speed remain constant. Now I'm asking you guys a question. Let's say we are not taking number of molecules here. I'm taking molecular fraction. If I take the molecular fraction versus speed, this Zoom is killing me. Molecular fraction versus speed. Let's say we have n number of molecules initially, then I was adding another n number of molecules. What are the shapes of those two diagrams, two conditions?
Is it the same? It's a ratio, right? Is it? Is it not? Is it not? It doesn't change, right?
It's exactly same because the fraction is same.
The fractions.
Understood? Like, let's say, uh, 1000 divided by, kidding me, 1000 divided by 20,000 or 2000 divided by 40,000. Exactly same values. So you are not getting this kind of two different graphs. Then you are getting only. Make a stuff. Again,
Patience.
slash ham again. Make it then patience.
Is it like usually?
Okay, see, then the both times, even n or even 2n, the shape of the graph, area under the curve is supposed to be exactly the same. Understood? Okay, so let's read this together. Topic, effect of number of molecules on distribution. When the number of particles get increased, the number of molecules with certain speed get increased by same extent. Therefore, shape of the curve remains constant. If the number of moles are considered in y-axis, area under the curve gets increased with the same shape. Also, the most probable speed, mean speed and root mean square speed remain constant. They are not changing. Okay, fill this part. Okay, let's read together. Let me read, just check your notes. Effect of number of molecules on distribution. When the number of particles get increased, the number of molecules with certain speed get increased by same extent. Therefore, shape of the curve remains constant. If the number of moles are considered in y-axis, area under the curve gets increased with the same shape. Also, the most probable speed, mean speed and root mean square speed remain constant. See how many times we are just reading the same thingy so you get the memory? Copy this. that is not symmetric, okay? Come on, what is this shape? This is very symmetric, isn't it?
Take this photo. Yes, this photo could see.
That's it. Now almost symmetric. Isn't it? I will make it stingy.
Should take it away.
Yes, I am the pants. You put down the pants. Oh, thanks. The pants, yeah? Oh. Just grab it from up here. What is it? Maybe the top right? Maybe the top right. Come on! Stop talking to me. Try this. Okay. Shush. Okay, online students, when you are drawing this, make sure that your structure is not symmetric. Okay, not symmetric like this. If you just do like this, if you go just like this is like almost symmetric. Just drag this more towards here, more towards your right. And y-axis, number of molecules with certain speed. X-axis, speed, meters per second. Speed, meters per second. Akasha, can you move on? Okay, so this one, I want this explanation from other Gisatitaven Athenu Kitting on Mathotaarachchi. Explain this. Just take your time. You can support her. When temperature increases, number of molecules with higher kinetic energy or higher speed is increasing, so that this side is supposed to be now greater. So the molecules with higher speed, this side is supposed to be now higher. Okay, if I go with two different colors, let's say I'm going to go with the new one with the green color. See, this has decreasing and this part is increasing. This much molecules are having now higher energy. Clear that? This much molecules are having now higher energy. So the graph is shifting to right, plus the highest number of molecules, the number of molecule is decreasing. Clear that? Also this value is increasing. Earlier most probable speed is here, now it's here. The new one is shifting towards again to right. Clear? Because the number of molecules with greater speed is now increasing with temperature. Okay. Effect of temperature on distribution. Is this part difficult? No, understanding is very easy. When the temperature is increased, kinetic energy of molecules get increased. Intermolecular attractions get decreased. When temperature increasing, molecules moving faster, so they don't have the chance to make the intermolecular interactions. Okay, so the movements are increasing.
This is increased.
What?
Intermolecular interactions. Is right.
Let's make it. Let's make it. It's wrong there. Okay. Hang in. Let's make together. Therefore, speed also increases. Since the number of molecules is constant, the curve spreads along x-axis towards right, lowering the height. The most probable speed, mean speed, root mean square speed also get decreased. Okay, before you read then, intermolecular attractions get decreased. Okay, we talked about this temperature effect of something else. What is that? Temperature effect of? We think you want to interact. London forces. Remember, London forces, what happened when the temperature is increasing? London force strength decreasing, because when molecules are moving faster, they are not getting chance to get closer to make this induction. Clear? Same thing I have written here to improve your memory. Okay, let's read this together now. Effect of temperature on distribution. When the temperature is increased, kinetic energy of molecules gets increased. Intermolecular attraction gets decreased. Kinetic energy is proportional to temperature. Therefore, speed also increases. Since the number of molecules is constant, the curve spreads along x-axis towards right, lowering the height. The most probable speed, mean speed, and root mean square speed get increased. Let me show you something. There are like variety of times where various times that they were asking you this graph for the exam. Then they were expecting that you are naming y-axis and x-axis, and then the second thing is they are giving marks for those. Okay, you have to start this from the origin, and then this is supposed to be the T1, lower temperature one supposed to be higher, higher temperature one supposed to be lower, and then again they are expecting this cross is supposed to be here. Otherwise, let's say if you are drawing this higher temperature one inside this, clear that? That's a totally different one. Understood? So the cross mean this is supposed to be increasing. The second one, okay, I mean this part is supposed to be increasing. The area with higher temperature is supposed to be, molecules with higher temperature is supposed to be, higher kinetic energy is supposed to be increasing. Clear that? Okay, when you're drawing, make sure.
Take the stream.
No energy, this is really frustrating. Okay, let's write together. Read together. Did you read this together?
Yeah.
Oh yeah. Okay. Now you're gonna fill this, and then draw the diagram. See, the Zoom isn't responding. Shall we close the app and start that? It's here if you want to copy anything. Okay, let me read this for you. Effect of temperature on distribution. When the temperature is increased, kinetic energy of molecules gets increased, intermolecular attractions get decreased, kinetic energy is proportional to temperature. Therefore, speed also increases. Since the number of molecules is constant, the curve spreads along x-axis towards right, lowering the height. The most probable speed, mean speed, and root mean square speed get increased. Okay, let's copy this. Maintain this imbalance. Don't make it balance again. Make it asymmetric bell shape. Okay. But they are only asking questions within the syllabus, isn't it? Yeah, it's difficult because you still don't know the syllabus because you only know like 4 subjects, 4 units. When it comes to December, we are in 10th month. Another 2 more months we have. Yeah, we would start Unit 5. Unit 4 would finish in most probably in 2 more weeks. 2 more weeks, yeah.
Then we start Unit 2 earlier, right?
What do you mean earlier? Not early in my class. It's earlier for other people.
Yeah, I mean, like in 3-4 weeks, right? We start.
Yeah, you mean unit? Yeah. In maybe maximum 3 weeks time, we're gonna start Unit 5, and Unit 5 is again very shorter one.
Okay.
And again, I'm going to give you guys the same sort of a note.
Okay.
And in the meantime, we're going to do a lot of questions at the class.
Ultimately, you're going to finish Unit 5 by December.
I guess we would be able to do, yeah. It's again shorter, like maybe that's maximum 5 weeks. But you guys are going like 4.5 hours. That's why this class is going really like little faster than all the other classes. Because they are going like after school 2:30 to 6. They have only 3.5. You guys are 4.5. But they are doing a separate paper class. You guys are not doing a separate paper class. So the solution is like within like in each like 3-4 weeks time we're going to do 1 day like the papers, or maybe half day paper and half day theory. Why? I need your suggestions. How would you want to go?
You have them separated.
Separate paper class? Like halfway theory, halfway papers?
Isn't that harder? Like, isn't that like more mentally like, exhausted questions?
If you only do questions?
No, like if you're doing theory and paper on the same day, don't you get more done if you have 2 separate classes?
Is it? He's saying like when you do halfway papers and halfway theory, you would feel more tired or something. Your brain get tired or something.
It's like if I'm taking questions, like my brain is like prepared for questions. If I'm doing theory, my brain is prepared for theory. If you do it in the same day, isn't that exhausting?
Then definitely your brain's supposed to practice both together. Though. So the best thing is to do both together. Because for the exam, they are asking like the theory, not like theory. Okay, these questions are from exactly theory part. These questions are from exactly coming from questions, calculations, and so on.
That's what I mean. Like,
they don't ask such like separately. So when they definitely we have to do halfway theory and halfway. They are laughing at you. Wine. අල්ලගන්න ක්ලාස් එකේ උනාට පස්සේ සෙට් කරන්න. මේ ගේට් එකෙන් යන්න දෙන්න ඇරියට කියලා.
But like, don't we get more done if you have 2 separate days? I'm saying separate day paper and a separate day theory. Yeah, it's that easy.
Discuss with you all. I am okay for whatever it is.
Because I'm only going to 3 classes.
Same.
Yeah, it's convenient for like that, right?
3 classes mean?
Like, like overloading, right? So it's okay to come to tangent.
I'm not getting you. Huh?
Okay, right.
Okay, I want this explanation from. Make it then. Anti.
Think about it. We're going to maths class in the morning. We're
Support
going to
her.
theory in the afternoon, and then again you're going to take the same day. Would you come to even take this?
Aman.
Yeah.
Yeah. During the break time, you guys sort it out. Now, Ranuti is explaining this. Yeah, in like before we maybe after done unit 4 or maybe like the next week or so we're going to do like anyway bring your unit 3 with you always, like keep it with you, unit 3 and 4. I guess you guys are through with unit 2. Unit 2 is not that difficult, I guess. Are you guys okay with unit 2? Why is Hari? She was like Smiling why you are having any issues with Unit 2? Unit 2, I know you guys can sort out with this like reviewing, but Unit 3 is the like challenging. So we can do a couple of questions at the class and likewise. Okay, Ranuti, explain this. When the mass is increasing, temperature at 10.
Ask me. Sorry.
Listening. We are discussing this question here. Okay, listening, explain this.
No. Got this.
Okay, Ranuti, explain this. The temperature is constant. So the mass is increasing so that when the mass is increasing, what happened to the volume? The speed. Speed is decreasing. So the highest mass is for C non. See, its speed is like decreasing. If you go with these all four, those are like smaller. But if you go with helium, which is having this lightest mass, so all these three different speeds are really higher. That's because if you understand this very easily, this kinetic energy is constant when the temperature is constant. So the mass is inversely proportional to velocity. With this equation, see the kinetic energy equals half ma square. Clear that? So kinetic energy constant, so the mass is inversely proportional to square value of velocity. So that's when mass is greater, velocity is supposed to be smaller. Clear that? Okay, let's write this. Listening. Listen at you and have an එහෙම වෙන්න ඕනේ ඉතින්. ඕගොල්ලන්ගේ age එකේදී කියවන්නේ නැහැ. අච්චමල නම කියවන්නේ නැහැ. Okay. Effect of molar mass on distribution. When the increase in molar mass, speed decreases. Therefore, the most heavy gas has the lowest value for the most probable speed, mean speed, and root mean square speed. Okay, read out loud together. Effect of molar mass on distribution. When the increase in molar mass, speed decreases. Therefore, the most heavy gas has the lowest value for most probable speed, mean speed, and root mean square speed. Fill it. Finish? Okay, let me read it for you to check your whatever we have written. Effect of molar mass on distribution. When the increase in molar mass, speed decreases. Therefore, the most heavy gas has the lowest value for most probable speed, mean speed, and root mean square speed. Okay, copy this. This one actually you cannot maintain exactly this. For all four you cannot maintain this asymmetric bell shape. So alarm clock is not here today, I guess. What is it with her? No. Just call her during the break time. The exact reason you're supposed to maintain speed is the final exam. You guys will have only 2 hours for MCQ, 3 hours for structure is MCQ. Everything you learn for 2.5 years. Don't you understand? If you guys grow, because every time like I'm giving these good life things to you guys, if you grow all those and adopt these for other 2 subjects as well, maintaining good marks is not harder. And the other thing, always challenge yourself that you will reach 100. It's not you are challenging to class first or the school first. Let's say she have reached 80 marks. So do you want to reach 80? No. When you are reaching 80, she is trying to reach 90 or she is trying to reach 100. So let's make your target is 100. Isn't it listening? So when others are trying to reach you, if you stay there, what's happening? What is your marks? Like, wow. How did you lose that 4 marks? Silly mistake. What did you do?
Did you have the term test?
It's a monthly test. Monthly? Yeah. Outlet test. Oh.
Yes, yes.
We have the highest.
Yes.
Oh,
Well,
first
yes.
one.
First.
Yeah. It's only for first grade.
First and second one.
Wow. Come on, you're not done. He's thinking, oh,
This is not my marks. Oh, I'm not
No, I was thinking about like proper exam preference for the
oh yeah, yes, you can ask that later, but complete.
What's the about that?
You have to write all those speeds. How many? See, these 2 you have to write down there.
I have to read the manual.
Oh. Just write everything down. And name these methods. All these are inert methods, inert elements. I guess we need to do some questions now. I mean the calculations, and you only doing like writing theory and filling spaces. Our brain is again. Yeah. Anyway, a little more theory is there. Can I move on? Oh, what time is it? Yeah, because you guys are not requesting. Because of Cindy, we miss you, Cindy.
You attendance in
When do we will breaks?
What's happened?
I have no idea. Okay, 3:10. 3:10 to 3:25. Okay, break time up to 3:25. Okay, online students, break time up to 3:25.
That's good. Please. Yes. We need. See that? One second. Miss, what's that called?
Huh?
This instrument thing?
Condenser. You guys know I did something silly.
We did do 10 minutes.
After the break, I have not recorded the